Anyone knows MATLAB? Anyone not know MATLAB? Knows, a couple knows. Any other exciting, like anyone Java? Got a couple Java people, C++. Okay, anyone already know Python and is just here to see if they can heckle me? All right, cool, I like you guys.
Sorry.
Any other languages in particular? Functional languages, schemes, Lisps? R, okay. Cool. So, I don't necessarily know all of those. Actually, I know all of them. I don't know R. That's pretty much it. So, if I get to any point where I mention a topic and I go, oh, this is what a string is, or here's a palindrome, and you don't know a word, interrupt me, let me know that you're lost, because I'm here to help you guys learn stuff and make it fun, and if you're lost, it's not fun, which is what I know from the majority of my classes. There was supposed to be laughter on that one was a joke. So, without too much else, let's get started. Let's talk about some stuff. So I'm going to start by going into a presentation that I forgot that I closed a moment ago. So let's fix that. So I've titled this Python and Other Nifty Things because how much we stay on topic is determined by what you guys care about and what you find interesting. I'm totally fine talking about Python for an hour and a half, and I'm totally fine if an hour into it somebody decides, ooh, we want to talk a little bit about bash programming, and I talk about how you can use command lines and do arg parsing in Python, which is a really, really easy thing because it has an awesome library for it. My name, as I mentioned already, is Sam, and there's the date in case you didn't know. Python, most importantly, is a snake. People love going to the zoo to mate with me because I always point it out. So more appropriately, Python itself is a high-level, interpreted, dynamically typed, duck-typed programming language that has loads of features. So high-level just means it's the closest we've developed so far to something that actually makes sense naturally to us. Now, I'm not saying Python is the only high-level language. Java's high-level, C++ is high-level, C is high-level, MATLAB's high-level. All these things are high-level. We can compare that to things like assembly code, binary, things like that are a little bit more on the machine scale and actually speaking in how the computer understands things. Interpreted. So an interpreted language, we don't compile it. MATLAB's interpreted. You just enter stuff and it runs. Compiled languages usually have the benefit of being a little faster, but we'll talk about that in a minute. Dynamically typed, so that'll mean, I'm going to show you that in a bit, we can assign any variable, any type of value. MATLAB, again, also has this feature, I think. Yes. If you're used to things like Java, C++, those are statically typed, meaning I must declare a variable is an integer or a string or a double or whatever type, and I can only assign those types to that variable. This slide really is only most important if you're familiar with other languages and you want a comparison of how they work. If you don't know much at all about programming, you can mostly ignore this. Duck typing is a really cool feature. So I'm sure a lot of you have heard the phrase, if it looks like a duck and it quacks like a duck, then it's probably a duck. Python has this in a lot of its function calls. While we don't have to necessarily verify that something's an array to call .size on it, we can just say, does it have a size method? All right, cool, then this works, which is known as duck typing. And brimming with features, which is what the next hour and change is about, however much time we have. What is it? It's 12:37, hour and 23 minutes. So Python is super easy to use. Python works in a ton of different environments. It's a portable language, and the canonical first program anyone should ever write is called Hello World. So we're going to start with that, and I'm going to show you a couple different Python interpreters is the wrong word, environments that we can use. Is this text all too small? Yes. All right, cool. Whoops, wrong button. So while I'm fixing that, There was something I wanted to talk about, and I don't know what it was. So I'm just going to show you the most basic of Python programs, how it works, how easy it is. Did everybody, or at least a large number of people, get Python installed on their local environment? Some number of people, everybody else has a buddy, they can look at their stuff. Or you can just watch me.
I think it's under appearance.
Which? Oh,
Appearance
thank you.
and font.
There we go. Yeah, I wasn't actually thinking, I was more talking and hoping something would pop out. Thanks, sir. Big enough? Too big, maybe. Oh, cool, that should work. So, most easy way, this is a Unix-style command line. Specifically, I'm using Bash. Doesn't really matter. Tux machines are run by the CS department, so I'm just logged onto a machine over in Ucross. But I've opened up Python. It gives me a little bit of basic information, when it was installed, which version, and how to get some basic license information from it. And the most simple Python program is just print hello world. And it does it. Ta-da! Oh, I'm off on the left side. Thank you. I do need more applause in my daily life, so if you want to...
Let's try again.
Yeah! So, if you have to do something like, what, this? So that means you have Python 3 instead of Python 2.7. This will still work in Python 2.7, and I really kind of hate that this has happened. The Python community in some way or another has had this schism where there's two different versions, and they're almost mostly entirely similar, but not quite. This is one of the biggest things that people notice is different. There are a few other minor changes. I actually don't know what all of them are because I've really only used Python 2.7. So if you do have that problem, you can try and reinstall it, and it shouldn't take more than 2-3 minutes. But otherwise, you can just kind of adapt the things I write to Python 3 style. Okay, well, that is why. So actually, I do have installed here Python 3.2. So you'll see what he was talking about was if I do that, actually let me, it's going to say invalid syntax. If I go back in and I add these parentheses, it works. So slightly different version of Python. There's historical reasons as to why it's different, and I don't know what they are, to be perfectly honest with you. So when you're in a Python interpreter to exit, you can either type in exit, or usually they'll give you an alternative. The Windows version, which I'll show you in just a sec, is called idle. And I don't know how to change the text size. There we go. So I don't really use this one, but this is just when you install Python, this white screen here, which again I need to slide over because projectors are jerks. There we go. So this white screen here is called idle. It comes with the default Python installation on Windows, and it works the same exact way. I can declare a variable dog equals corgi, and I can just say print dog. I can say dog equals dog plus dog, which, as many of you would guess, is string concatenation. So it takes one instance of this, puts it here, another instance, puts it here, sticks them next to each other, and we get corgi corgi, which doesn't really make sense because that's not a dog. What I was saying earlier about being dynamically typed, we can then say dog equals 9, which will work just fine. Why does Python let us do this? Because why not? We can assign any variable, which a variable is just an identifier, any value. Which can be a problem at different points when you're trying to do something and you say, oh, let me assign this based on a function. So if I have a string like, I'm getting slightly ahead of myself, I hope you don't mind. I also can't type all the time. if I do something like this, I can say dog.reverse. And that's not what I thought it was. So quite often in programming, you will forget exactly what you're trying to do. Oh, I already have this open. So you can pull up the documentation for a language, which Python's, I like the format of. It's this right here. In general, you just can Google Python, whatever you're looking for, in the docs. Does everybody know what a string is? Yes? Anyone not? Okay, cool. Not losing anyone. Verse. Oh, I know why. Nope. I missed the last letter, right? First letter. 6. Oh, it's -1. There we go. So this actually is something really cool about Python. It's got this.
Leave the middle one empty.
What did I do wrong?
Colon, colon, -1.
Colon, colon, -1?
Yeah, without the 6.
Oh,
there you go.
or with the 6. Okay. So Python has this really cool, basically what we're doing with this colon representation here is we're defining a range of values. So if I say 3:6, I can't do it outside of the string because it's a slice. So essentially what I'm saying though here, dog, we're treating it when we do this as the individual characters inside of it, which are C, O, R, G, and I. This is saying start from the 6th letter, go to the negative first letter, and increment by -1s. So it starts at the end of the word and just pulls it backwards. We could do something similar, and we could say -2, and it would probably give us every other letter. So if we have C, O, R, G, I, that grabs us every other letter. You can do a lot of cool stuff with this type of representation and this type of format. And again, getting ahead of myself, so I'm going to come back to that. But the point of it is, assuming you know what you're doing, which apparently I don't at the moment sometimes, Python is really easy to just do a lot of things, reversing strings and doing magic with stuff. I like to refer to Python as magic because it is a little bit magic. So back to the topic. Python's cool because it's way fast if you do it right. So for example, we have to understand what our data structures actually do and how they work under the hood for this to work correctly. I know you guys have all used arrays. I don't know if you've used, they're alternately called like hash maps, dictionaries, maps, depends on the language. Python calls them dictionaries. But we can use a dictionary to associate from different types or types to values, and I'll show you that in a second. But it's important to understand these because if we use them poorly, everything's going to be slow no matter what you do. But if you do things right in Python, and we use things like NumPy, which is a scientific calculations library, and depending on what else you can do, you can use PyPy, which actually cross-compiles to C. But so if you do things right, Python can be way fast. There's graphs on different websites. I think PyPy has it. It shows essentially performance, and of course they don't have what I'm looking for because they've changed their website since. Regardless, the last time I looked at this, essentially we had a graph that shows, oh, here's the speed, I think it was a bar graph, of a particular C++ program. Here's the speed of an equivalent PyPy program, which is just, again, a cross-compiler, Python to C++ or C. And they were nearly identical, which is a good thing because, as I mentioned earlier, classically interpreted languages are slower because they first have to Yeah, first I have to interpret instructions into machine code and then run them. So it's just an extra step. Cool. So I showed you already a couple things. I showed you idle, and I still want to show you these four. So these are different options for editors. My personal favorite for Python is an all-purpose text editor called Vim, which I can... Vim is kind of something that if you have a lot of time to invest, is a great time investment if you're going to be programming and doing a lot of, what do you call it? Just typing in general. So it's your classic like 1970s, 1960s command line editor, has all kinds of shortcuts. My mouse actually doesn't do anything. I can't, the cursor is this green block in the upper left corner. That one. And so I can't move my cursor with my mouse, which immediately you're thinking, this is a terrible idea. Why would you do this? Which, trust me, I thought it too. The cool part is, and this is kind of lost because you can't see my fingers, but I'm moving the cursor with H, J, K, and L, which is really nice because I can be doing that, realize, oh, I want to rename this the rotation matrix. And my fingers don't move off my keyboard. I don't have to go find my mouse way over here, start doing things, put my hand back, keep doing things. That's a huge waste of time. And while you might be, Sam, that's only finding my mouse, which, you know, goes from here on the keyboard to over here. It is a huge waste of time when you do it all the time. Whereas instead, if I can just hit the escape, so there's, without going into too much detail, Vim's a modal editor, and as you see how in the bottom left here, we are now in insert mode. In insert mode, H, J, K, and L stop being the movement and they just type. So I'm going to undo that. But so I hit escape to go back to command mode. I can move to wherever I want, change what I want, undo it, whatever. Go back a word, go forward words. I can delete lines, paste them. I can delete the whole file if I want. Oh, wrong button. You know, I can delete the whole file, which this file is 345. I can go to line 108. You know, lots of stuff. Not super important that you actually learn it here because I've been using Vim for going on 4 years now, and I've scratched the surface of what it can do. Although everybody loves a nice set-based find and replace statement. Okay, I'm going to stop playing with that because I really like them. Emacs is another one. I don't know Emacs. Historically, there's a religious war as to which is better, VI or Emacs. Don't get involved in the religious war. Pick an editor and learn it if you like it. It's similar but different. That's all that's important. Wrong button. Okay, cool. Spider is the one that I was officially mentioned as a, hey, you guys should go download this. Partly because it looks kind of like the MATLAB environment. Again, stupid left-hand side of the thing. A little bit different. So up here in the upper right, we have a help window, essentially. So if I was to make an object over here on the left and say array equals square brackets, I believe that there's a way. I haven't used this much, to be completely honest with you. No, that is the definition. I don't know. I actually don't know. Source, editor, object. Ah, there we go. So there we go. So I've typed in, I've done something here with an array variable. I made it a list. I typed in here, oh, tell me more about this object. And, you know, it's giving me some information that's useful and helpful. Helps me either to debug my program or just figure out what the heck I did. And in this case, I think you saw in this corner, this is an interpreter. So whenever I type something, it happens now. This is a file editor, so it lets me write a actual longer file in the same way that in MATLAB you can have the function windows and the script windows, or you can just use the main interpreter. I have MATLAB on this too. I can compare that if anyone. Does anyone want me to open that up and show you the equivalent? Because I think everybody gets it. Cool. Another one, I like this company. Again, I haven't used this editor particularly much. This is called PyCharm. It's related to, well, it's from, what's their company name? JetWorks? JetBrains. So the company name is JetBrains. This is JetBrains. This is called PyCharm. Again, I could make this larger if you want, but we're not going to be I don't think I'm going to be working on this too much. This one I find is pretty useful for bigger projects. You have, this shows us all the external libraries we're referencing, our libraries. I can open different files in tabs right here. And we've got a lot of neat and nifty tools. We can refactor things. We can, I think they run different analysis tools in this one. You can analyze the stack trace. You can launch a Python console from in here. All kinds of neat things. I would probably go for using this if I was doing a huge project, but I like Vim. As I mentioned, I'm biased. I'm a very biased source, so don't take my word for it. Try out different things, figure out what you like. And we mentioned idle, wrong thing. There we go. There's tons of others. I don't know much about them. So we mentioned strings. Important things to note. MATLAB, strings are single quote. Python, double quote or single quote, same thing. This, however, is going to give us an error. Can anyone guess why?
It's a name of another variable. Sam is a name for another variable in this case.
Right, so it's trying to interpret Sam as a variable instead of as a string. So if I do that, it's going to tell me this variable is not bound to anything. Specifically, no, that's not a thing. Okay, we're going back here because I like this better. So specifically, if I said name equals Sam, it's going to tell me Sam is not defined. We don't have a variable for this. If I wanted to say Sam equals, this is my name. And then I said, name is Sam, it'll work. But if you were thinking, oh, well, name is Sam now, right? Yeah, it's the same string Sam had. But what I've shown in the slide, if I do single quotes, it is the same as if I use double quotes. Interesting thing to note, it always prints out as single quotes. Doesn't matter. Our primitive data types. So primitive data types are integers, floats, doubles, Boolean, which Python has true and false as Boolean types. So I could say so for example, this is a Boolean value. I just said B is, and then this right here on the right side is interpreted as 4 is equal to 7. So we all know that 4 is not 7. So if I print B, which print is optional in this case, B is false.
Question is that, when is print optional and when is it not?
Print is optional when you're working in the terminal. So in this case, because it's an interpreter, I've listed a variable and it knows that all I want to do is just print it out, basically, or inspect it. If, for example, I wrote a... That's interesting, I'm getting a phone call from Illinois. If, for example, I wrote a Python file and I called it temp.py and I said A equals true A, and we do python temp.py. So this is used to run a file. I get no output because saying A in that context isn't going to print to the screen. I mean, I know that's not the most hard and fast of definitions, but it gets the idea across. If I change it to print A, we get true. So we have an age of 45, which no, I'm much younger. Thank you, though. We add age in 10 and we get 55. Now, we can then assign age to dolphin. Is this a good idea? No. So we can do it. We can do a lot of things in Python, but for style purposes, it's a pretty crappy idea to assign something we were using as a number to a string, just because it doesn't really make any sense. Unless suddenly we go to, there's a thing with Hebrew numbers, the letters are the same as the numbers, and there is a practice that I can't think of what it's called, if anyone can help me out. What?
Kabbalah.
No.
For what?
It's the gematria? No? I don't know. The idea is that you can interpret different words different ways based on what their numbers add up to and stuff. I don't know. I remember reading it in a book, which is vague, and I'm sorry, it's vague. Chaim Potok's The Chosen. They talk about it. I also have a Jewish family, and they're not that Jewish. So then another thing, we have a different variable, which this age, capital, different from that one. I'm sure you all know this, case sensitivity. What's this going to do? 4 times a string. Doesn't really make sense, but it does something, and it does something cool. Does anyone know? Does anyone have a guess?
This will be out 4 times.
Yes, it will concatenate it 4 times. So we're going to go over to the screen. And now we have a commercial. Meow mix. All right. You guys don't like my jokes. I'm sorry. I'm trying, doing my best. I got claps again. Thank you. So commenting. Commenting is important because, I don't know about you guys. Come in. I forget what I'm doing like 10 minutes from now, so don't interrupt me too much. Single line comments, just single line comment. Triple quotes, this is 3 single quotes, is a multi-line comment. Not that exciting. Data structures, this is where things get cool and a little bit different from other things you might know. So I'm sure we've all had an ordered list of things before. Groceries, or results, or anything. We use lists for that in Python, and there's a great question, which is the underlying implementation of a list actually an array? And the answer is, we can figure that out, but I don't know. If you don't know what that means, not that important. Arrays in Python, or lists in Python, are 0 indexed. 0 indexing means that the first element we put in it is stored at position 0. So for this example, we've created an empty list. That's what these square brackets do. And we've said groceries got append milk. So let's just go through this because it's easier than me talking about it. If I can spell again, this would be great. So we print out groceries and it's an empty list. Not exciting. Now we can say groceries.append milk. So we're adding this to the end of the list, and if we print groceries, again, this doesn't matter if I do print or just write it, this is the same thing. We get milk in a list. So then I can say, now append ice cream, because ice cream's good. Who doesn't like ice cream? Cool. Frog legs. We're making some weird dish if we're using milk, ice cream, and frog legs, but that's okay. So really easy to add things. Now, if I do groceries sub 1, which this is known as sub 1, it's a subscript or an index, we get ice cream. So milk is in position 0, position 1, position 2. Am I belaboring the point? Am I being boring? Is this about the right speed for you guys? Okay, cool. I always hate going to presentations and then being bored. And I try not to be boring because of it. So lists are really cool when I say, for example, so I'm just going to find some data I generated for the project at one point. Man, this would be easier for me if it was smaller sometimes. It's decided to hang on me, which is problematic. There we go. So, for example, I had a project where we had different people. Essentially, they were simulated people that would give off different amounts of heat based on what they had with them. They would move around, and depending on who I am, I'm going to have a different ideal temperature. I might want to be really hot. You might want to be really cold. Vice versa. We might have people who want to be at the average temperatures, whatever. They would move different distances to each other to try and make themselves feel good. So, for example, one such trial, this was the output. And it's a little bit easier to see when you're not, in giant text mode. But essentially, we've got what step number we're on in the simulation. And after that, we have the average